Assalamualaikum and hi. I am Ain Nazira and I want to present about the water reticulation design. The first step for water reticulation design is the pipe network layout. For this project, it has consist of 3 loops and 9 nodes. Next is to determine the pipe properties. The pipe material used is galvanized steel and diameter of pipe is 0.3 meter. And the length of pipe also have determined. Next is to calculate the water demand calculation for phase 1. Demand for kindergarten is equal to 55 liter per day per student. Is equal to 1,100 liter per day. Demand for MOS is equal to 135 liter per day per person. Is equal to 2,700 liter per day. Demand for residential is 1,360 liter per day times 201 houses. Assume that house is the single story terrace house type. Is equal to 273,360 liter per day. So that the total water demand for phase 1 is equal to 0.0032 meter cube per second. Next is to determine the flow scenario calculation. Peak flow is equal to 2.5 times total water demand is equal to 0.008 meter cube per second. For fire flow is equal to fire risk plus total water demand. Assume that the fire risk is a class D risk equal to 1,140 liter per minute plus total water demand is equal to 0.022 meter cube per second. Therefore, use fire flow as design flow is equal to 0.022 meter cube per second. So, this is the layout of distribution and the flow rate in the pipe have been determined. Next is to performing head balance method for each loop. To get the H value is equal to KQ power of n, whereas the n is equal to 2. To get the delta Q is equal to negative total H over n total H over Q. To get the Q prime is equal to Q plus del Q. For joining pipe, Q prime is equal to Q plus Qi minus Qj. The iteration is done until the total height is equal to 0 or delta Q is equal to 0. So this is the iteration 1 for loop 2 and loop 3. So next is calculate the residual head. To calculate the residual head, we need the friction loss in the pipe. So friction loss is equal to FLQ square over 3.03 d power of 5. Therefore, the friction loss of in each pipe can be determined. So, the residual head is equal to elevation level plus H minus top water level must be greater than 7.6 meter. So, for this project, we can see that we can get 7.6 meter, greater than 7.6 meter. Next is to design the water tank reservoir. Top water level is equal to 65.47 meter. Bottom water level is equal to 62.4 meter. Total daily demand equal to phase 1 plus phase 2 is equal to 0.055 meter cube per second. Land area is 105 times 45 equal to 4,725 meter square. So that the proposed water tank area is equal to 90 meter times 30 meter. Tank depth equal to 3.70 meter, and the structural height is equal to 13.07 meter, and the volume provided is 8,289 meter cube. So the elevation level equal to 52.4 meter. Hydraulic grade line is equal to 67.01 meter. That's all. Thank you.